All right, so picture this. It's the summer of 1969, right outside a little town called Cumberland, Ohio. And standing there in the dirt is a machine. But calling it a machine feels wrong, you know? It's more like a monument to human ambition, or maybe human arrogance. This thing towers 15 stories into the sky. 15. Its bucket alone, just the bucket, could swallow a 2-story house whole. 325 tons of earth in a single bite. The boom stretches out like the arm of some mechanical god. And when it moves, when those electric motors hum to life and that bucket descends into the overburden, the ground trembles. Workers standing 100 yards away can feel it in their boots. They called it Big Musky, officially Bucyrus-Erie 4250W. The W stood for walking, because this thing didn't roll on tracks or tires. It walked. Massive hydraulic feet lifting and planting, inches at a time, shaking the earth with every step. Construction Equipment magazine that year called it, quote, the most powerful single bucket excavator ever constructed. And they weren't exaggerating. Nothing before it, nothing after it has matched its scale. Big Musky represented the absolute peak of what mechanical engineering could achieve in earth-moving equipment. But here's the thing nobody talks about. Big Musky didn't just move earth. It moved an entire company straight into oblivion. See, the company that built it, Bucyrus-Erie, they'd been around for decades, giants in the industry. Their machines carved the Panama Canal. They built the shovels that dug rail corridors across the Midwest. By 1910, the Bucyrus name meant quality. It meant reliability. It meant permanence. Their factory sat right there on the shores of Lake Michigan in South Milwaukee, Wisconsin. The air smelled like coal smoke and cutting oil. Massive riveted frames, gears you could walk through. Everything visible, everything repairable. Their 1895 catalog promised contractors machines, quote, built not for seasons, but for generations. And that wasn't marketing. That was survival logic. See, back then, contractors didn't buy equipment every few years. They bought once. They repaired forever. The market ran on durability, not innovation. But by the late 1940s, though, something was changing. Excavation technology was hitting a ceiling. Cable shovels were enormous, sure, durable, absolutely, but slow to adapt. Every time you increased bucket size, you exponentially increased structural stress, swing inertia, maintenance downtime. Trade journals at the time noted a hard truth. Productivity gains were flattening. At job sites across Pennsylvania and West Virginia, contractors were pushing machines to their mechanical limits. Boom cables frayed under load, gears stripped, cycle times stretched as machines grew heavier. And it wasn't just Bucyrus-Erie facing this problem. Marion Power Shovel, P&H, all the big names, they all hit the same wall. The question wasn't whether someone would break through. The question was who would risk everything to try. Bucyrus-Erie's engineers, they leaned into electricity early, not hydraulics, electricity. By the 1950s, their walking draglines and stripping shovels ran on massive synchronous motors fed from external substations. An internal engineering memo from 1956 argued that electric power scaled better than diesel. Fewer moving parts, infinite torque at low speed, lower lifetime fuel costs. And you know what? They were right. Operators trusted it. Dealers could service it. Utilities could feed it. At the South Milwaukee plant, test benches hummed with prototypes late into winter nights. Engineers calculated load factors and power curves by lamplight. But electric drivetrains meant complexity. Every sale required coordination with power companies, specialized substations, cable management infrastructure. You weren't just buying a machine, you were buying a system. And in 1966, they decided to scale that system to the absolute limit. So in 1966, engineers at Bucyrus-Erie finalized plans for something unprecedented. The designation was clinical, 4250W. The reality? Biblical. Central Ohio Coal came to them with a problem. They had deep overburden, thick layers of earth and rock sitting on top of coal seams. Moving it was expensive, labor-intensive. They were running fleets of smaller shovels, dozens of operators, constant maintenance. The costs were killing them. They asked Bucyrus-Erie a simple question. Could one machine replace an entire fleet? Now, most engineers would have laughed. One machine replacing an entire fleet, the logistics alone. But the team at Bucyrus-Erie, they didn't laugh. They calculated. Design documents filled entire filing cabinets. Structural calculations required new computing methods, early computers that filled rooms. The boom span exceeded anything ever built for construction equipment. One internal memo described it as, quote, concentrating an entire fleet's capability into a single operational unit. A company brochure declared one machine, one operator, one solution. And here's what they designed. A walking dragline excavator standing over 150 feet tall, weighing 13,500 tons, powered by multiple electric motors generating more than 13,800 horsepower. The bucket alone, 220 cubic yards. That's 325 tons of earth per pass. To put that in perspective, a modern dump truck carries about 20 tons. Big Musky moved more than 16 dump trucks worth of earth in a single scoop. Project engineers knew the risk. Concentrating that much capability in a single unit meant concentrating all the vulnerability too. No backup, no redundancy, no retreat if the economics shifted. But Central Ohio coal needed overburden moved faster than any fleet could manage. Bucyrus-Erie sold them on the vision. Simplicity at extreme scale. Fabrication began in 1967, but here's the problem. You can't build something that big in one place and then move it. No rail line in America could carry it whole, so they spread fabrication across multiple plants. Components arrived at the Cumberland site oversized, slow, deliberate. Workers bolted steel plates thick as phone books. The boom alone weighed more than a loaded locomotive. Welders worked in shifts around the clock, their arc lights visible from miles across the Ohio countryside. Local residents would drive out at night just to watch the blue flickers flickering against the sky. The bucket was fabricated steel with replaceable teeth. When it was finally assembled, workers joked it could swallow houses. They weren't wrong. You could park 3 full-size sedans inside it with room left over. Assembly required coordinating deliveries from Wisconsin, Pennsylvania, subcontractors across the Midwest. Cranes lifted sections into place, while engineers verified tolerances measured in fractions of inches. By late 1968, the frame stood complete, dominating the skyline like industrial architecture from another century. When a machine can't be moved, you know what that means. The job site becomes permanent. Big Musky wasn't going anywhere, ever. It would work that mine until the coal ran out, or the machine died, whichever came first. The walking mechanism was, honestly, it was insane. 4 massive hydraulic shoes, each one larger than a car. They'd plant the entire 13,500-ton weight settling onto them. Then the front shoes would lift, swing forward, plant. The rear shoes would lift, swing forward, plant. Over and over, moving the entire machine inches at a time. Standing next to it during a walk cycle, the ground literally shook. Not vibrated, shook. By 1969, Big Musky was ready for its first bite. Central Ohio coal executives flew in. Engineers from Bucyrus-Erie stood by with clipboards. Local newspapers sent photographers. This was going to be historic. The operator climbed into the cab, high above the machine's base. From up there, workers on the ground looked like ants. He engaged the motors. That deep electric hum, you could feel it in your chest. The bucket descended, teeth biting into overburden with controlled violence. Electric motors strained, then steadied. The swing mechanism rotated smoothly, dumping earth into waiting spoil piles. The sound wasn't a roar. It was a deep mechanical groan, punctuated by the crack of stressed earth. One pass,
325 tons moved. Cycle times were astonishing. What took an entire fleet of smaller shovels hours to accomplish, Big Musky did in minutes. Central Ohio Coal reported immediate, dramatic reductions in labor cost per ton. The numbers looked incredible on paper. One operator supervising this mechanical giant instead of dozens of operators running dozens of machines. Fuel costs dropped because electric motors were more efficient than diesel engines scattered across a fleet. Industry journals ran headlines, "The Future of Surface Mining." Engineering publications published detailed analyses of its drive systems, its structural innovations, its walking mechanism. When a machine becomes infrastructure, you know what happens? It stops being a machine. It becomes a monument.
At full stride, Big Musky was unbeatable. Its bucket cast shadows across acres. The walking mechanism moved the machine inches at a time, yes, but when you're moving 13,500 tons, inches are miracles. Operators developed rhythms measured in tons per hour, not cycles per minute. The machine operated around the clock when conditions allowed, illuminated by floodlights that turned night into industrial day. From miles away, you could see those lights glowing against the Ohio sky, could hear the distant electric hum carrying across farmland. Engineers visited from around the world to study its operation. Photographs appeared in technical journals, equipment catalogs featured it prominently. Universities brought engineering students on field trips. Big Musky became famous, not just in mining circles, famous. But perfection, perfection narrows options. See, while Big Musky was perfectly engineered for one job, one place, one economic assumption, the world kept turning, and the market was changing fast. Through the 1970s, the energy sector shifted. Environmental regulations tightened. The Clean Air Act, the Clean Water Act, new reclamation requirements. Strip mining faced increasing scrutiny from environmental advocates and regulators. Suddenly, mining companies needed to restore land after excavation, replant vegetation, manage runoff. All that added costs. Coal economics wobbled, energy demand patterns changed, natural gas became more competitive, nuclear power expanded, and meanwhile, financing grew more cautious. Banks looked at projects differently. But here's where it gets interesting. While Bucyrus-Erie was focused on perfecting Big Musky, their competitors were focused on something else entirely. Caterpillar, Marion, and P&H were refining fleets, multiple smaller units with higher uptime, better dealer support, standardized parts. See, if one machine in a fleet broke down, 3 others kept working, but if Big Musky broke down, everything stopped. And Big Musky broke down. Not catastrophically, but regularly. A failed motor meant waiting for specialized parts from Wisconsin. A damaged boom section required fabrication lead times measured in weeks. No spare unit, no redundancy, no workaround. Central Ohio Coal's entire production schedule hinged on one machine's uptime. Maintenance crews worked preventatively, replacing components before failure, but the complexity meant constant vigilance. Small problems cascaded quickly. An operator later recalled in a survey that, you didn't run it, you supervised it. Control levers required precision, not force. The cab vibrated with contained power. Below, the walking mechanism shifted the entire frame inches at a time, hydraulic feet planting and lifting in mechanical rhythm. When it worked, it was magnificent, but when it stopped, the efficiency gains vanished instantly. The margins were thin, downtime was catastrophic, and competitors had learned the lesson. They'd watched Bucyrus-Erie prove the extreme, and then they sold moderation. Trade shows in the mid-70s featured reliability statistics. Dealers emphasized serviceability over spectacle. Contractors began calculating total ownership costs, not just purchase price. The market was shifting towards systems thinking, overlapping capabilities, shared parts inventories, flexible deployment. Big Musky represented the opposite philosophy, ultimate specialization. And specialization, when the market moves, becomes isolation. Caterpillar expanded its dealer network.
Parts arrived overnight. Operators could be trained quickly. Financing terms became more favorable for distributed equipment purchases. Banks preferred lending for fleets because risk was distributed across multiple units. Hydraulic excavators gained power and reliability. Diesel engines improved fuel efficiency. Wheel loaders offered mobility that walking draglines couldn't match. The very engineering that defined Big Musky now isolated it. No other mine wanted something so specialized. No contractor could justify the capital concentration. The machine continued working through the 1980s, moving overburden as designed, but it existed alone in its category. Engineers at Bucyrus-Erie proposed scaled-down versions, but the economics never aligned. The breakthrough that seemed universal in 1969 proved site-specific by 1979. And the company? Bucyrus-Erie was bleeding. Their machines were still excellent, quality remained uncompromised, but excellence wasn't enough. The market rewarded companies that could deliver parts overnight, train operators quickly, offer flexible financing. Scale advantages in manufacturing and distribution became decisive. Caterpillar had dealers in every state. Bucyrus-Erie had expertise, reputation, legacy. Markets don't reward brilliance, they reward coverage. By the early 1980s, Bucyrus-Erie was struggling. Market share declined, revenue dropped. The company that had built the Panama Canal, the company that pioneered electric drive systems, the company that built the biggest excavator in history, was losing.
Big Musky worked until 1991, 22 years of operation. Not because the machine failed, but because the economics did. Central Ohio coal exhausted the reserves that justified such extreme equipment. The coal seam played out, the overburden was moved. The mine reached the end of its economically viable life. And when that happened, Big Musky became obsolete. Not broken, not worn out. Obsolete. See, with smaller machines, when a mine closes, you load them on trucks, you move them to the next site, you sell them on the used equipment market. But Big Musky, it was built on site. It walked to its position, and it was never, ever going to leave. 13,500 tons of steel sitting in a played-out mine in Ohio. The machine that cost more than $25 million in 1960s money, that moved more earth than entire fleets, that represented the absolute pinnacle of excavation engineering, became a problem. What do you do with something that can't be moved and has no purpose? For 8 years, it sat there, silent, rusting, a monument to ambition and miscalculation. Meanwhile, Bucyrus-Erie was dying. The company had been weakened by competition, market shifts, the narrowing demand for their specialized electric drive systems. Other manufacturers had adapted faster, diversified better, built stronger dealer networks. In the 1980s and early 1990s, Bucyrus-Erie went through mergers, asset sales, restructuring. The brand that meant permanence, that promised machines built for generations, was being carved up and sold for parts. The irony is brutal. The machine outlived the company's independence. In 1999, Big Musky was dismantled. Cutting torches separated boom sections that had operated as one for 30 years. The bucket, that massive 220 cubic yard bucket that could swallow houses, was cut free and transported to Miners Memorial Park in southeastern Ohio. It sits there today. Tourists photograph it, surprised by the scale. Children climb on it. Plaques explain what it was, what it did, but standing next to it, you can't really grasp what it meant. The bucket, just the bucket, represents an entire philosophy of engineering. Bigger is better. Consolidation creates efficiency. Specialization achieves perfection. And all of those assumptions? Wrong. Or at least incomplete. See, today, every modern electric mining shovel carries Big Musky's DNA. The scale studies, the stress modeling, the electric drive logic,
That's all still used. Marion developed their own large shovels. P&H built massive excavators. The lessons were absorbed into incremental improvements across the industry. But nobody builds them that big anymore. Nobody concentrates that much capability in a single unit. The lesson wasn't that big machines don't work. The lesson was that big machines are fragile. When you put everything into one machine, you create a single point of failure. Not just mechanical failure, economic failure, strategic failure. Bucyrus-Erie bet the company on extreme specialization. They built the biggest excavator in history, proved it could work, and then discovered that proving something works isn't the same as proving it's profitable. Their competitors learned from them, watched them succeed, watched them struggle, and then built business models that avoided Big Muskie's weaknesses while adopting its strengths. That's the brutal truth of innovation. The pioneers get arrows in their backs. If engineering alone decided survival, Big Muskie would still be digging. But markets don't care about engineering excellence. They care about availability, serviceability, financing terms, dealer networks, parts inventory, operator training, resale value. All the things Bucyrus-Erie couldn't scale. The company that built the Panama Canal, that pioneered electric drives, that pushed excavation technology to its absolute limit, disappeared. Not because they failed, because they succeeded too narrowly.
So, here's where we end up. The bucket sits in Miners Memorial Park, rusted, preserved, admired. Families picnic nearby. Kids climb on the teeth, those massive teeth that once bit through hundreds of feet of overburden every day. A plaque explains that this bucket, just this bucket, moved millions of tons of earth, that it was part of the largest single bucket excavator ever built, that it represented the pinnacle of American industrial engineering. But what the plaque doesn't say, what you can't really explain on a piece of brass mounted to concrete, is what it cost. Not the $25 million, not the thousands of man-hours. The real cost. Big Musky represented a philosophy, the idea that you could engineer your way past complexity by embracing scale, that bigger was always better, that specialization created invulnerability. And for 22 years, that philosophy worked. The machine moved Earth better than anything before or since. The economics, on paper, were sound. Central Ohio coal saved money, at least when the machine was running. But that philosophy, that belief in ultimate solutions, it made Bucyrus-Erie brittle. While they were perfecting Big Musky, Caterpillar was perfecting dealer networks. While they were celebrating engineering excellence, their competitors were building parts distribution systems. While they were designing the world's largest excavator, the market was moving toward modular systems and operational flexibility. The future arrived. It just didn't have Bucyrus-Erie's name on it. Today, if you visit a modern surface mine, you'll see electric shovels descended directly from Big Muskie's engineering. The drive systems, the motor controllers, the swing mechanisms, all influenced by what Bucyrus-Erie learned building that machine. But you won't see anything that big, because the industry learned the lesson. Diversification beats specialization. Availability beats capability. Good enough, repeated reliably, beats perfection delivered once. The engineering that created Big Musky lives on in 100 different machines, refined and distributed across the industry. But the company that created it? Gone. Erased from the industry it helped define. That's the real story of Big Musky, not the machine, the cost. Standing next to that bucket in Ohio, you can reach out and touch the steel, run your hand along the teeth, feel the scale of human ambition literally rusting in front of you. And maybe that's the point. Innovation without adaptation is just impressive failure. Bucyrus-Erie built the biggest excavator in history. They solved problems nobody else could solve. They pushed engineering to its absolute limit.
and they proved that being the best at one thing isn't enough if the market decides it needs something else. Big Musky moved mountains, but it couldn't move markets. And in the end, that's what mattered. The bucket sits there, silent, massive, rusting slowly under Ohio skies, a monument to the idea that bigger isn't always better, that perfection can be a trap, that the pioneers who break through often don't survive the breakthrough. If you ever find yourself driving through southeastern Ohio, stop by Miners Memorial Park. Stand next to that bucket. Try to imagine it suspended 15 stories in the air, swinging over an active mine, 325 tons of earth cradled in steel. Then imagine the company that built it, gone, erased from the industry it helped define.